All right, so I made the triple integrals homework instead of due today at 5, it's due tomorrow at 5 if you noticed. So I think today's class will really help with that first triple integrals homework, and then the second triple integrals homework, we'll see. I'll start it at Monday at 5, and then if you need more time come Monday, then we can push it back. But so there's like going to be 2 assignments open at once, right? So the one due tomorrow at 5, and then the next one we'll initially set at Monday for 5. Okay, so let's go back to this example. We found the plane that was this top slanted plane, right? And we wrote it in the 3, or I gave it to you, but once you find that plane, it's easy to solve for z, solve for y, solve for x. So that's all the same plane, written in the 3 different as 3 different functions. And so now I want to look at what we called type 2. And so what was the first, the ones that we called type 2? What was the first variable of integration? The first variable of integration we looked at as type 2. X. So yeah, we're going to do dx or x first. And so then we would say, what would the start of our chair be for that? Left to right. What do you think? Back to front, right? Because now x comes out at us in R3. X comes out at us. So we're going to do back to front, right? So type 2 starts with back to front, dx. All right, so what is the back and what is the front of this thing? What is the back and what is the front of this thing? So we'll start with the back. So I'll give it a spin again. Understand, sometimes it's... There we go. What's the back and what's the front in terms of x? So one thing I think is really helpful is to think about an archer. You know, we're talking about something with archer, right? Honestly, that was not planned. So for back to front, the archer stands behind the solid, okay, and fires arrows into the solid. And so the question is, where do those, when we're talking about the lower limit of integration, where do those arrows pierce into the solid? Through what surface or surfaces do the arrows pierce into the solid? So first of all, is it one or more than one surface if the archer was behind, shooting at you guys, right? You're ducking. Hopefully the solid is going to slow down the arrow, right? So here comes the arrows from behind, shooting forward in the positive x direction. Will those enter the solid in one surface or more than one surface? More than one surface. So what do we think? Maybe this view helps. One or more than one? One, right? It's just one. What surface is it? So it's just this triangle right here, this surface that has this triangle in it. It's just x equals 0, right? So there's that, x equals 0. And then for the upper limit of integration, we ask, okay, so now the archer shoots a bunch of arrows. They all enter in x equals 0, right? They all enter in x equals 0. Put it up here. Technology is beating me here. Things moving. Stop. Okay, and now I want my pen to work. Okay, so we said back to front, so 0. So then the front. So now the arrows pierce in the back through x equals 0, and then they come out the front. They come out the front. Do they come out through one surface or multiple surfaces? Some people are saying multiple. Do you see that it's more than one surface in the front of this thing? Right? So we've got what? We've got our plane, and then also what? This plane that's kind of this slanted plane that kind of also forms the bottom of it, but in this case it's forming the part of the front. See that? That forms part of the front. For the arrows that are shot for low z values, arrows that are shot at low z values, Pearson at x equals 0 there, and then come out x equals 0 through this plane down here, which is different than this plane up here. So that means we're going to split it up. This time, so last time we saw one, we split it up where the surfaces, there was only one surface to surface. That was this, type 3? So when we did type 3, there was only one left surface, and there was only one right surface. Do you see that? The left surface was y equals 0, and the right surface was our plane here. But what made it two double integrals then? Two triple integrals? The double integral, right? So then when we got to the double integral, so the inside integral of dy was the same because there was one surface on the left, one surface on the right. But then when we got to the outside double integral and we did dx dz, we had different right-hand sides of our projected region. So our dx was split up on the right according to z going from 0 to 1 or 1 to 3. 3, I think that is 4. 4. 0 to 1 or 1 to 4. So now this one is split up. The one we're doing now is split up for a different reason because of the actual surfaces in the inside integral. Okay, so we're going to go from 0 to, wow, stop. Okay, from 0 to, what is this? X equals, this surface under here was z equals 1/2 x, is that right? Or x equals, is that correct? This is 2, 0, 1? That's right, okay, 2, 0, 1. All right, so sometimes x goes from 0 to what? So let's do the bottom first. 0 to 2z. When it comes out this here. And then sometimes it goes from 0 to, so when the arrows are shot up here more, enters in at 0, exits out where? This one right here, right? Yeah. So I think before, just for writing's sake, I called this z1, y1, x1, right? So we want 0 to x1, which would be written as that right there. So now the outside double integral is dependent on which surface it comes out of, right? When it comes out of 2z, so now let's look at the projection for the outside double integral. So we look right straight at the yz plane. Close enough. Stop moving. Is it moving or not? Stop. Right, that's good. So when it comes out, the front is this bottomish plane. So what we want to do, we're going to do type 1. We're going to do B2. This is B2. Now B1. What do I want? Yeah, I want B1. So because I want, what is that? Bottom to top, left to right, right? Bottom to top, left to right. That still looks like a 2. Okay, so B1. So when it comes out to Z, we have, this is the 2Z, right? So then our outside double integral is going to be for that part of the projection. So bottom to top is what? So this is the point in the YZ plane. 0, 1, this is 0, 4. This is 3, 0. Yeah. So then what will it be? It will be bottom to top, which will be from, so this is, we're doing dx, then dz, dy, bottom to top, left to right. That's type 1. Okay, so z goes from 0 to this right here. Right? This is, and we need what? Z as a function of y. So what is that? Is that 1 minus 1/3 y? I got a z-intercept of 1 and a slope of -1/3. And then y goes from 0 to 3. So I'll just stop there. That was a very disjoint delivery of that. So did you follow what's happening here? So when the arrow comes out, the bottom-ish surface, that's the front, right? That's this front at the bottom, 0 to z, then your double integral is for that part, the projection of that part of it. So that triangle there. So we go 0 to this line, which is 1/3, 1 minus 1/3 y. Then from left to right, 0 to 3. Okay, then when we come out x1, when we come out this plane, we're going to go bottom to top, which is, what's the bottom? No, the bottom is this line again, 1 minus 1/3 y. To top is this one. Well, that looks like 4 minus 4, is it 4/3 or 3/4? 4/3. Now this is the orange, so now when we come out x1, which is our slanted plane, the double integral has to be the bottom of that projection. So 1 minus 1/3 y is this here, to 4 minus 4/3 y is this here, and then from 0 to 3 again. All right, please ask if I lost you. They only get harder from here. Please ask if I lost you. Yes, please.
The second integral, the very dx, why does it go from 0 to x1 and not 2z to x1?
Because this is back to front, right? Okay. Back to front. The back is always 0, and then the front changes. The front is either this thing or this thing. So that's, the front is the orange one, which is our, that's the plane that slants through all the axes. Other questions? Okay, so now what about B2? Would we have to split it up? Okay, so we still have to split up the x-planes. Now we get to the double integral on the outside. What's going to happen? Do you see? So I still have to do what? 0 to 2z, and then 0 to x1. So what am I doing now? I'm doing dx, dy, dz. What's going on?
When you're calculating like the partial or the integral of like the larger plane, you're gonna need to split that up because the function defining the minimum y value is like it goes from just y minimum is 0 to that line right there.
Mm-hmm. Yeah, so now we're going left to right and then bottom to top like this. So what happens here? What's the left side of this triangle? What's the left side? It's split up, right? Part of it is 0 and part of it is this. So now this triple integral where the front coming out at you is the x1, that would be split again. And you'd end up having 3 triple integrals. So you have the one coming out 0 to z is fine. We can do that in 1. But then this one up here, that's for a double integral going left to right first. That has to be split up again. Again, according to when z is from 0 to 1, then your left side is going to be this blue line there. And when z is 1 to 4, then your left side is going to be 0. So I'm just kind of talking strategy there. You can practice that one at home. Okay, any questions? All right, let's look at another example. So now I have, I want to talk about my solid is x squared plus y squared equals 4, z from 0 to, z equals 5 minus y, and z equals 0. So I want you to sketch that. So you don't, when you're doing your homework, you don't have the fancy pictures. You have to have some ability to sketch and see. So I want you to sketch x squared plus y squared equals 4, z equals 5 minus y, and z equals 0. And I want to start by, I want you to set up A2, type A2. So sketch the solid and see if you can set up type A2. You're either making progress or you're getting help. Okay. Hopefully this was pretty smooth sailing. DZ means the archer is where, shooting which way? Where's the archer shooting which way? DZ. Underneath, shooting straight up, right? Shooting straight up. So I'm underneath here. Does it enter through one surface or more than one surface? Only one surface. What surface is that? 0. And then goes through the solid and then it exits, right? Where does the arrow exit? Does it exit through one surface or more than one surface? 1. Once z equals what? 5 minus y. So now we got, so that's that. So it's bottom's 0, top is 5 minus y everywhere. So 0 to 5 minus y. All right, and then now with the outside double integral, we project this thing into the xy plane, right? Project in the xy plane, and what do you get? Yeah, you just get the disk, right? So if the shadow of this thing or this thing smashed down at the xy plane would just be the solid disk, right? And this is? Radius is? Okay, so then type 2 is dx dy, left to right, bottom to top. So left side. So now you can do the archer again on your double integrals. Where's the archer? Dx? left side shooting into the region. One curve or more than one curve for the left side? Is that one curve or more than one curve? It's just one curve, and that is y equals, or let's see, x equals? And then the arrow exits out the region through one curve or more than one curve? So it has one right side, which is positive version. And then y goes from -2. Oh, that should be. Questions on that? But then some of you had an epiphany. You said, oh, it'd be so much better if you do polar for the outside double integral, right? So now if your outside double integral, a cleaner, no square roots, actually no functions, right? All constants and no square roots, do polar. So in polar, so now we have f dz, and then what? dr d theta? R dr d theta. The r would link up with the f, right? Become part of our integrand, the thing we integrate. And r goes from, let me just write it down. So easy, right? 0 to 2, 0 to 2 pi.
So you don't have to convert z to a polar value?
No, it's still z. Z is still z. Polar is just only the plane. We still have z is from 0 to 5 minus y. So the one thing you would have to do is this, right? This would have to be in terms of r and theta. What? R sine theta, right?
Should it be from -2 to 2, or should it be 0 to 2?
R d theta. What is r?
Oh, radius. Okay.
Yeah, 0 out, right? We're shooting. Here the archer is standing in the origin, shooting out, right? Shooting out radially from the origin. Got it.
What is radially?
What's that?
What's radially?
Along radii. Okay. B2. Go. B2. B2, that what was our B? X first. Dx. Dy dz. That's right. Okay, is it one triple integral or some? Do you need more than one triple integral to do this? Because of the inside or because of the outside double integral? Good, okay. So check so the inside, the back and the front is always the same, right? Back and the front is the same for the whole. But then when we get to the inside double integral, the left side is always -2, but the right side is either that or that according to this z value. What's the z value right here?
3.
Is this 3? So when z goes from 0 to 3, what is the right side? When z goes from 0 to 3, the right side is 2. When z goes from 3 to 7, this is 3, 5, and 7 up here. When z goes from 3 to 7, the right side is 5 minus z. How'd we do? Anybody ask if they're just going to get harder, so ask. Good on this one? C1. Go, C1. We're having fun now. Nope. dz dx. dy dz dx. Left to right. Left to right. Bottom to top. No. Left to right. Bottom to top. Left to right. That plane, y equals what in terms of x and z?
Five minus.
5 minus z. It's the plane. So the fact that it's a disk, that's taken care of in the outside double integral. Like what part of the plane we have is the outside double integral. But the plane, the points on that plane don't know what the boundary is. They're just the points. Z equals 5 minus y. So it's y equals 5 minus z. I have one nod. Does that make sense? Okay, now for the fun part, right? So what does the projection look like? Just a rectangle?
Wait.
Not quite.
It's like a weird, like a bullet.
And then rounded top, but there's more to it.
Circle.
But then we've got this too is important, right? So even though that's not on the left side, it's on the right side, we got to include it, right? So that's what the projection looks like. So now we're doing what? dz dx, bottom to top, left to right. So where is this? Entering in the vertical cylinder, exiting out the vertical cylinder. Is that exhibit A down here or exhibit B up here? Exhibit A, right? This part here is this integral. And then this part up here, where we exit out the circular, the disk, that's the plane, that's this one. Okay, so do this first one here. So bottom to top. What's the bottom? Z goes from 0 to 0 to what?
3.
Not 3. This, right? So this, we're talking about right through here, right?
Square root of 4 minus y squared.
So this is the intersection of these two, right? It has to be in terms of x. Z equals something in terms of x. So it's equal to, Z equals to 5 minus root 4 minus x squared. And that's from what to what? Negative 2 to 2. Now over here, Z goes from what to what? That same. So now for this up here, we start, the bottom is the same as the top on this one, right? So this is the 5 minus square root of. And then 5 plus. And that's from what's what? Okay. So you can still, even though you got a weird projection, it still works with just one double integral for each, so that it doesn't have to get split again. Okay, questions on this? Let's just talk through C2. We'll just talk and draw. We won't set it up. C2. So C2 will be the same. It'll be the same deal with this inside integral, right? Be cylinder to cylinder. and then cylinder to plane. But now we're going to do dx dz. So let's talk cylinder to cylinder, this one. Can I do it in one? Actually, 3. Because you have, that was not well thought of. You have this, you have this little triangle here, and that little triangle there. So this one would have to get split up into 3. Then what about this? Left to right first. Nope. So this is all 1. So this one does not need to get split up when you do dx dz. But this one has to get split up into 3 different things. This rectangle, that little shark fin that side, that little shark fin on that side. So this ends up being 4 double integrals added together. You're lucky class is over.